Okay, hey guys, this is, what lesson is this? 10? This is the Die-Alder lesson. I will put it in there. I've already done it, but I wanted to incorporate the star method that he talked about during class, just in case anyone was unsure of how to do that or wanted more information on that. Okay, lesson 11, actually. Okay, so first we're gonna do the star method, and basically what I'm going to do, okay, let me clear that. I'm just gonna put little stars. So this is my diene, and this is my dienophile. So my diene will have the electron donating groups, and this will have the electron withdrawing groups, my dienophile. So I see that this will have the majority. Let me okay. I'm sorry, I'm trying to put it like too big or too small. Okay, this one will have the majority of, this will be my electron donating group. And what we're gonna do is we're gonna skip 2, or like, we're gonna count to 2. So we're gonna go 1, 2, this is gonna be where my next star is. And then we're gonna count 1, 2, this could be my next star. Now we're gonna go to the dienophile, and we're gonna find where the electron withdrawing group is, and it'll be here because oxygen is more electronegative, so it's actually withdrawing electrons from the whole pi system. So I'm going to put my little star on that withdrawing group. This is my donating group. This side's my withdrawing. So I'll put a little star right there, and I'll do the same thing. 1, 2. So I've got it there. So it looks like we're gonna line these two up so I can leave it exactly how it is. I don't have to turn it around because I can't put these together because there's 2 things in the way, but I can put these 2 together. So that's where I'm gonna start connecting everything. Let me clear this out of the way. Okay, and then the second part of this is, let me fit it. So I see it's Z conformation, and yeah, that looks about right. These 2 are on the same side. So what I want at the end is a trans conformation. So I'm going to move this bond from this side because I want this carbon to connect to this carbon. And then I'm going to move this bond to the carbon over here. And then I'm going to move this one down over here. I'm going to hit arrange. And then we see Z, so I'm going to make sure that we have trans at the end because the conformation is going to switch. So whenever we have cis, it's going to be trans, and whenever we have trans, it is going to be cis. All right, let's see if that did it. Yep. So this is my end product. I've got a 6-member ring. I've got my oxygen, single bonded oxygen, trans to the double bonded oxygen. And let's see if that came out right. So I probably won't go through the whole lesson. I just wanted to kind of show how to use that. So this one's really straightforward. We can just add so this one's going to be the donating group, and this is going to be the dienophile with the withdrawing group. And typically I like to add them at the bottom of the double bonds, so I'll put it here, and then we're going to skip. So 1, 2, on 2 you're going to put it, and then bottom of the bond. This one doesn't matter because these bonds are exactly the same either way you turn it. So I'm going to connect these 2 using my heterolytic function. I'm going to grab from the top of the bond because I want to connect these 2 carbons, not these 2. I'm going to grab over here, connect it to this carbon, and then connect this, move it down because I don't want any double bonds next to each other. We don't have to worry about trans or cis because there's no confirmation on this, so we can leave it as is. Okay, I'm gonna identify which is my diene and which is my dienophile. I see a double bonded oxygen pulling electrons away from this system, so I know this is going to be my dienophile, and I know I'm going to have my withdrawing group down here. Single bonded oxygen is going to be donating because it's got all these loose pairs of electrons that can easily go back into the system. So I'm going to get my paint out again, and this is going to be my electron donating group. I'm going to go 1, 2, 1. I'm gonna go back over here. 1, 2. Okay, this, I've already talked about this. This is my electron withdrawing group, so I'll put it down here because this oxygen is pulling electrons away from everything. So I'm gonna go 1, 2. I've got the bottom. I'm gonna line it up. So I see these two ends have the stars. So I'm gonna turn this one around and then we can work on it. Not both of them, just one. And then I'm going to move it down. And there's no confirmation, so I don't have to worry about that. You can always double check, but usually it'll indicate. So I'm going to grab from here so I can connect these two carbons. And then I'm going to count 1, 2, 3, 4, 5, so I'm going to connect it over here. If I connect it here, it'll just be a 5-member ring. And then I'll take this double bond. Sometimes it's hard to see the double bond, that's why I like to count a little bit. So at the end, we have our para-functional groups at 1 and 3. So let's go ahead and submit that, and this gives me that double bond next to the single bonded oxygen. Okay, this one doesn't really matter either because this is symmetric, but we can still do the counting. So usually when I have my just carbons, methyls, you know, those are usually good. These are all good like donating groups. But we see here on my dienophile, we have that oxygen double bonded pulling electrons away. So I'm going to do my withdrawing group right there, and then 1, 2, I'll put it down here. And then lastly, we're going to look at our dienophile, and I like to put it on the bottom of the double bonds. So I'll put 1 right there, and then 1, 2. And you don't want to go this way because you want to stay within the ring portion, or like the ring we're going to make. So now I'm going to connect these. So these two line up. So I can leave it like that, and I'll get this bond, attach it there, get this bond, attach it over here, and then connect that one to the bottom. We don't have to worry about E or Z because it's good just the way it is. Okay, this will be the last one I do. And first we're going to look for dienophile and our diene. So I see that this oxygen here has 2 lone pairs, so it can be donating electrons. So this is our electron donating group. I will put a little asterisk there, and then I can just go ahead and do the counting. 1, 2, so put it down here, and then 1 and 2, put it down here, and then this will be my electron withdrawing group. This is taking electrons away from the system, so I'll put right there, and then count 1, 2. Okay, so these two line up, I can't do it here because there's a bulky mess on top of both of them. So this is the orientation that we wanted at. All I gotta do is move this one a little bit down just so it can be kind of in the middle between these two. Okay, and then let's see, I will resize it and zoom in a little bit and move some things around just like that. And then I see we have an E conformation, so at the end I'm going to make sure that it is cis. So I grab that bond, grab it up here. I've got 1, 2, 3, 4, 5, 6 carbons. So this is the carbon I'm going to be connecting it to. Connect it down here, hit arrange. And then lastly, I'm going to check that my carbons are cis and my groups at the end are cis and they're not. They are trans. So I'm going to move them, hit arrange. And I also don't like a funky looking molecule, so I'm going to try to make it look a little better. Okay. Perfect. I have that cis conformation going on, opposite of what E is. So cis, same side. Got my hydrogens on the same side and my functional groups at the same side. Let's see if that is correct. Okay, so that is it. I hope that helped a little bit if you were curious about how to use STAR method. And yeah, good luck.